Hello friends, welcome to ITS workshop. This is Praveen. In this video, we would like to discuss about what is big data and what is Hadoop and how Hadoop can be provided as solution for big data. So the agenda for today's talk is what is big data, how big data is how big is our data universe, and what are the various sources of big data. Four V's of big data, what are those? Data storage and analysis of big data, and how Hadoop can be one solution for big data. So let us see. So what is big data? Any data which is large enough for the underlying system to handle, or you can say large volume of data which includes both structured and unstructured data, that becomes big data. So there is no particular boundary like after certain GBs of data will become big data or will be known as big data. It can be GBs for someone, it can be in TBs, it can be in PBs for someone. It's totally a relative term, we can see. So if we have some data and which can be in the form of structured data like general RDBMS data saved in rows and column in MySQL Oracle database or in Excel sheet like that, or we have data log server or photographs, images, videos in that form, and some tweets data or some JSON data, any format data. It can be structured, it can be semi-structured, it can be totally unstructured data. So the same amount of data can be big data for company A and cannot be a big data for company B. So if something is big data for company B, it doesn't mean that same data will be big data for company A, because company A has got some systems which can handle that sort of data. So like certain PBs are there, those can be big data for company B, and big data, those are not big data for company A. So same data, but it's not the amount of data which we can declare as big data, but it is relative term and depends from companies to companies. Okay. And next question arises like how big can be our universal data? Universal data including everything, whatever we have, we as human beings, and our machines, computers, those are generating. So what can be the possible size of that data? So according to IDC, there are some research there has been some research on this, and there are some predictions and some facts also presented by them. And these are the facts that every day we create 2.5 quintillion bytes of data. So that's a lot of data, and still there is not a tool which we can measure, but it's like some research data, so we can believe on this. And one other fact is that 90% of this data which the world has got today, it has been created only in the last 2 years. So you compare all data from beginning from the computer age and till now, and whatever data we have generated, that is just 10%. But two per in last 2 years we have generated huge amount of data comparative to everything. So whatever we have today, that data is large enough, and 90% of that data, today's data, has been generated in last 2 years. So this is also one fact. And other thing, the production of data is expanding by 4,300% increase. So that's a lot. It's not 100, 200, 4,300% increase annually. So if you if you calculate, it's just 2017, and every day generation of data is getting increased. We have got mobile phones, sensors included everywhere. Sensors are generating data countlessly, and all our pictures putting on social media, tweets, news, our cameras, all geolocation information. So you can imagine that a large amount of data is being generated every second by all of us and our machines. And this is really a huge amount of data. So you can see, like, if we see, big data is definitely the big enough, and the challenges comes when we want to store and analyze this big data. IDC, according to IDC estimate, the digital universe at 4.4 zettabytes in 2013, and it is going to be 44 zettabytes. So if I talk about zettabyte, what can be a zettabyte? We know 1 byte, kilobyte, megabyte, or GBs. GBs or photographs are in GBs. 1 TB we keep hard disk, 1 TB hard disk, like that. So up to 1 TB disk storage, we are supposed to deal every day. It's like, it's just normal for us. And if we talk about 1 petabyte becomes 1024 terabytes. So that's a lot itself. And 1024 petabytes becomes exabyte, and then 1024 exabyte becomes zettabyte. So we are here dealing with terabytes. Maybe in coming years, couple of years, we start dealing with petabytes also. So that's how the data generation is going to increase day by day. Now there are some sources, some examples we can consider, like how this data is getting generated, from where this data is generated. There are a lot of sources, but let's see a couple of examples. New York Stock Exchange generates about 4 to 5 terabytes of data per day, and Facebook is generating 2 7 petabytes per month. So that's the rate at which it is going, and right now it has got 240 billion photos and other items. There is one website, ancestry.com. It has got some 10 petabytes of data. So 10 petabytes of data they have to manage, they have to analyze, they have to provide results and insights from that data. You can consider the Internet Archive, which stores around 18.5 petabytes of data, and in Geneva, Large Hadron Collider, which generates 30 petabytes of data per year. And there are other sources like air-based data and social media, like we have discussed Facebook. So there are other social media also, like Twitter is generating, YouTube itself is generating a lot of data. So these are the some examples which you can consider. So this big data is definitely a big enough, the huge amount of data, and it's just a relating term. There is no hard line where you can say that this is big data and this is not big data. It's like that. And it has got 4 attributes, like volume, variety, velocity, and veracity. So volume means the scale of data. So definitely we are generating data in petabytes each second, every minute. There are some systems like Facebook is growing at 7 petabyte data per month. So it's growing like that. So it's about, volume is about large volume of data, the scalability of data at which it is just increasing. There is no decrease, there is no constant, it's just increasing. And second V stands for variety. So we have got data in various forms, like structured form, which is rows and columns, and unstructured data like our images, videos, binaries, and semi-structured data like JSON data and these tweets and all these stuff. So there are various varieties of data. It's not just plain spreadsheets anymore. There are definitely data in many forms. And velocity stands for analysis of streaming data. So velocity, it means the rate at which this large amount of data is getting generated is too high. We have got nice storage. Our storage capacity is growing nicely, but the amount of data which can be calculated is growing at such a speed that we are not finished with the analysis which we generated last day, and today new data is coming. So we are still doing analysis, and tomorrow new data is coming, we have to do that analysis. So the velocity at which this data generation is going on, the speed is really high, and we need to streamline all this data for analytical purpose. And veracity stands for uncertainty of data. Like it's not necessary that all data is useful or there is not fake data. Obviously you can consider like 27 to 30% data which is getting generated contains some fake data also. So that may include results in our insights, so we have to be careful about it. And there are some technologies by which we can put it aside. So these are the 4 V's, known as 4V, or so in some cases you will find like 3 V's of data: volume, velocity, and variety. But nowadays people are including veracity also. So these are known as 4 V's, 4 V's attributes of big data. So big data is always coming in large volume with lot of varieties and at very high speed, and it contains veracity also, uncertainty also. Next thing, okay, we have got big data and it's huge amount of data. It has got 4 V's. Now what we do with this big data? So companies are trying to find ways and means so that they can analyze this data, they can get some insights, and they can generate some business values. They can convert this data into some millions and billions of dollars. That's what companies are looking for. So this is the amount of big data which we have right now totally in your system, and this is the amount which we know, which we calculate generally, and this is the amount which we don't know. So you can compare your big data scenario with iceberg. So we know and we deal with only the tip of the iceberg, and rest data is still for processing, is still available for processing. You can generate insights out of it so that it may give you some business values, you may perform better in the business. Like let me give you one example, like Facebook and YouTube, and these these uh, these platforms provide search results, like recommendation, you can say recommendation engine. So these provide recommendation, and you sometimes you may find that you may be interested in these videos. So they calculate those videos, they recommend those videos using these big data technologies, and they provide the insights to you, so that it gives them more engagement. You'll go and check, oh yes, I want to see videos like this. So they are calculating it proactively for you. They are calculating this big data so that they can get more information that you may be interested in these videos. And like Amazon is providing ads based on your history, based on so many parameters which they are: age, gender, location, country wise. So they are calculating that amount of data for everyone Then they are providing some suggestions, some advertisements according to user, some email for the particular user, so that people are getting engaged more and system is becoming more smarter, and they are trying to provide the correct information for this for the customer, so that they may have more business. That's how they are dealing. So these in Facebook, you may know these people that comes like this, and you are interested in these videos, you may be interested in these videos, these companies. So you can see all social media platform, and they are dealing with big data, they are calculating big data, and they're providing you recommendation. This is just one of the use cases, there are other use cases also. So that's what company is looking for. They want to generate more insights from their data. So now we have got big data, companies want to analyze that more. Now how we can do this? So there are two facts which you can consider. Like, storage capacity has grown exponentially, but read speed has not kept up. In 1990, we had storage in terms of MBs, 1400 MB, and transfer speed you can consider 4.5 MB per second. So if we need to read entire drive, it would take only 5 minutes. So 5 minutes you can read 1400 MB. Now the capacity is growing. So obviously in 2010, if you consider, or the current scenario if you consider, obviously that is very smarter than this. We got 1 TB storage, and our average transfer speed 100 MB per second. So we can read entire drive in 3 hours. So it takes 3 hours for reading entire drive. We have got good storage capacity, but you can see that this read speed is not increased, has not been increased to that rate which it should be like. So we have got large disk, but it's taking much time for reading those disks, like 3 hours. So this is how we are we got big data, and obviously storage capacity is nice, but the read speed is not that good which we require. That's the current scenario. So there can be one solution for this, how to store your large amount of data and how to perform analysis on your big data. So why not reading from multiple disks at once to reduce time? So in last case, you saw that we are reading just from one disk, we are performing this read. So instead of using single 1 TB, why not we can use multiple disks which contains 1 TB together. So if we consider this scenario, imagine we have got 100 drives and each holding 100 of data working in parallel. So it would just take 2 minutes to read entire data. So that's how it is, and that's how Hadoop does this. Hadoop reads your data in parallelly and in distributed manner. So instead of having one big single disk storage and reading from single storage, why not we divide our data in parallel nodes in multiple disks and then reading from that. So that's what is the idea behind Hadoop system. So we got big data, we want to perform analysis of big data, and it's not good just performing analysis from one disk. That's how we need some parallel system which can read from multiple disks, and the one solution for this is Hadoop. So Hadoop reads from multiple disks, and we'll see how it does that. Now there are two things which we need to consider when we talk about reading from multiple disks. So this is just one idea, why not reading from multiple disks. So one is possible hardware failure. So if you have got one disk, that's fine. If you have got 100 disks and you are trying to read from all of them, there are more possibilities of getting some disk failed, and there are more possibility of hardware failure. So in Hadoop we have got HDFS and MapReduce. So HDFS solve this problem. HDFS is pretty good when we talk about system failure or hardware failure, or you talk about fault tolerance. So we'll see how it does that, but HDFS solve that problem. And now the second requirement is combining data from multiple disks after reading. So okay, you are reading from multiple disks and now you need to combine the result or the intermediate result. There are various stages at which you need to combine your result, and you need to provide single result to the client or the user of the system. So reading from disk and then combining the intermediate result, that is the requirement, and this requirement is solved by MapReduce. So we have got MapReduce programs which deal with combining all results from multiple disks very nicely. So it handles very nicely. So reading from multiple disks, and for hardware failure we got SDFS, and for combining results we got MapReduce. So that's how it does. So Hadoop has got two things, SDFS and MapReduce. That's in the core part of Hadoop. Now if we need to define what is Hadoop, like how from big data Hadoop is coming into the picture. So big data is large amount of data, and it's like coming with 4Vs, coming at larger speed, varieties of data, and there's a lot of data. So that's how big data is. Now we want to perform analysis, and Hadoop is there, which uses the idea of reading from multiple disks. So we can define Hadoop as a reliable, scalable platform for storage and analysis. So it is scalable. Definitely you can vary from 100 node to 200 node, from 1000 node, from 10,000 node. You can increase your nodes like this, and so if your computation requirement is getting increased, you just add the nodes and you get more computation result within same time. You can do like that. So we talk about linear scalability. So Hadoop provides near linear scalability. And one more benefit, like it runs on commodity hardware. We don't need fancy hardware for Hadoop. You don't need supercomputers for smart calculations. So the result of it, that everybody can use Hadoop, even me, you, and all the small companies and big companies. Anyone can use Hadoop for data analysis. So you have got large amount of data, government is providing large amount of data, there's a lot of data coming and available on the internet. You just download that large amount of data, you run your MapReduce application, and you got some couple of nodes, 4 nodes, 5 nodes, even that is also like sufficient if you are dealing with pretty large amount of data. So you got your commodity hardware, you don't need to go for the big hardware, big costly hardware, just some cheap hardwares are fine. And one more benefit is it is open source. So you don't have to have license for it, it's just available. You can uh, you can provide your contribution also to the Hadoop Apache Hadoop project, and definitely you can use it with as like normal open source. So this is very nice open source technology which we can run on general cheap commodity hardware, and this is reliable system. Definitely people are using it, all big companies are using it, and you can scale from 4 node to 5 node, from 10 node, from 500, from 10,000 node. You can scale like that. So it's providing an affordable solution for your big data. So using Hadoop, we can analyze our data and we can store our large amount of data. So storing large amount of data and reading that large amount of data for analytical purpose, that's what Hadoop does. So big data is a problem for the people, for the companies, and Hadoop is providing solution for this. And big data has got we when we call Hadoop, we generally are discussing with Hadoop ecosystem. It has got these different projects which we see in coming slides. That's how Hadoop does, and that is big data. So you can find more details and resources from Hadoop the definitive guide. If you like this video, please click on like button and subscribe for more videos like this. I hope you got better idea of big data. Thanks for watching.